Very good morning, students. Today, the discussion of my topic is a structure of atom. It is new chapter. After completion of some basic concepts in chemistry, now I will discuss today a structure of atom. Dear students, as you know, the meaning of atom proposed by the John Dalton in 1808, that atom is indivisible, indestructible, as well as it is the smallest, extremely small particle of the matter. But when modern atomic theory came into existence, the proposed model of atom given by Dalton was outrightly rejected. As per the modern atomic theory suggested by J.J. Thomson, Goldstein, Rutherford and Niels Bohr, all they suggested unanimously that atom is very much divided into two areas, two domains, two parts. The first one is the nuclear part and other one is the extra nuclear part. So dear students, here one is the nuclear part and other is the, what is there now? Extra nuclear part. Nuclear part includes nucleons. Nucleons, that is composed by protons and neutrons. But extra nuclear part, that is the electrons, that is very much present in orbit, and finally orbit concept was changed and that is known as orbital, where there is maximum probability of finding electron near to the nucleus. I will discuss at the right time. Here there are two domains of the atom. One is the nuclear part and other is the extra nuclear part. That means we can say atom has three fundamental particles mainly, that is the electrons, protons and what is there now? Neutrons. Dear students, there are three main fundamental particles of atom was electrons, protons and what? Neutrons. So tell me anybody who discovered the electron and in which year? Actually, electron was discovered in 1896 and proton was in 1886, a bit earlier than the electron, and then neutron in 1932 or 31 most probably. Therefore, who discovered the electron? Electrons was discovered by J.J. Thomson. J.J. Thomson. So write down protons. Proton was discovered by Goldstein and neutrons was discovered by James Chadwick. James Chadwick. Dear student, atom is neutral in normal state because they possess equal number of electrons as well as equal number of protons. Minus and plus neutralize to each other and hence atom is neutral in normal state. My dear students, here one thing, J.J. Thomson discovered the electron by discharge tube apparatus. Discharge tube apparatus. Same way here, discharge tube apparatus and neutron were discovered due to radioactivity. That is why it took time to discover or explore the existence of the neutron in the nucleus of an atom. Actually, it was in 1895 Henry Becquerel discovered the phenomena of radioactivity, alpha, beta and gamma rays, and the properties of the radioactive rays was explained by Professor of Physics Rutherford, an American chemist who explained the idea about the properties about the alpha, beta and gamma rays, dear students. So J.J. Thomson, by discharge tube apparatus, Goldstein and James Chadwick. Now, the very important area is that charge of electron equal to minus 1.602 into 10 की power minus 19 coulomb. Charge of proton plus 1.602 into 10 की power minus 19 coulomb, and neutron is neutral, so it does not have any charge. Now dear students, charge of mass of, who calculated the charge of the electron? It was calculated by Millikan with the help of oil drop method. So it was calculated by Millikan based on the oil drop method. Right now, and the charge of proton was calculated by Goldstein, and so far as neutron is concerned, no charge. So what about the students? The mass of the electron. Who calculated the mass of the electron? It is J.J. Thomson. All right. So complete this. So dear students, here see. Further I write mass of electron was calculated by J.J. Thomson, and then it is the mass of electron is calculated as the ratio between charge to charge mass ratio. So you know charge of electron is minus 1.602, since atom is neutral, so we not necessary, we don't carry the negative charge. 1.602 into 10 की power minus 19 coulomb divided by charge to mass ratio is 1.67 into 10 की power 8 coulomb and per gram. So dear student, coulomb cancel out, and it finally becomes 19.11 into 10 की power minus 28 gram. So far as in kilogram is concerned, it is divided by 1000. Therefore, in kg, 9.11 into 10 की power minus 31 kg. So you have to remember actually charge and mass of electron. Now come to this side, proton. So you see charge of proton is same as the charge of the electron, only the difference in sign because atom is neutral. So here mass of proton is calculated by E upon E by m ratio. The mass of proton is calculated as 1.602 into 10 की power minus 19 coulomb divided by 9.58 into 10 की power 4 coulomb per gram. Coulomb cancelled out. Now here it becomes 1.approximately 76 into 10 की power right now 20, minus 24 gram. And what about in kilogram? 1.76 into 10 की power minus 27 kg, because to change gram into the kilogram, let you divide by 1000. So that is why it is the mass of proton. So dear student, so mass of neutron is same as the mass of the proton. So this is the discovery of, you can see you have already done in previous class. Right now, electrons are the source of the cathode rays. So here right, electron represents what rays? Cathode rays. Picture tube of the television works on this principle. So cathode rays, and then see, you can change the materials for the electrode, cathode and the anode. You will get the same value of the charge and the mass. That is why electron is considered as universal constituent of atom. but not proton. You can change the gas taken in the discharge tube, you can change the gas, but ultimately you will not get the difference in the charge and mass of the electron. That is why electron is considered as the universal constituent of matter or atom. So therefore, electron means the cathode rays, source of the cathode rays representing the electron. They travel in a straight line, they can ionize the plate, they are made of the material particles, and they can affect the photographic plate. They also produce the heating effect. These are the general properties we have done in previous class, so we don't want to go in detail or the general idea what are the properties of the cathode rays. But here, since we are in senior class this time, it is pertinent to mention the charge as well as the mass of electron. Thus, we come to conclude that electron is one of the fundamental particles of an element which carries 1 unit negative charge, and electron is considered as 1 unit negative charge, and mass is equal to 1 upon 1837 parts by mass of which atom? Hydrogen atom. Thus we just imagine how small the quantity of the mass. That is why the total mass of atom lies in the nucleus of the atom, and electron has neglected mass. It is very that you can say the infinite. That is why the mass of electron is considered as negligible. As a matter of fact, that the mass lies in the center of the atom, which you can say it is the nucleons, that is ultimately called as the nucleus of an atom. Dear students, what about the protons? So protons are, anode rays. Actually, it is not produced from the anode, but due to the bombardment of the gaseous particle under the high voltage and low pressure, that the hydrogen gas going to break into H positive, and this proton move towards the negative pole. As such, it is known as anode rays. But it is misnomer that like electron, these are produced from the cathode rays, negative to positive pole. So that is why it was taken as cathode rays. But actually, in case of the proton, you keep in mind, it is not produced from the anode, but the particle which is obtained due to the bombardment of, in between anode and the cathode, due to the hydrogen gas present in the discharge tube. As such, it is called as proton, because nucleus as a whole move towards the negative pole. That is why anode rays, or you can say what rays? Canal rays. They also produce the heating effect. They travel in a straight line. They are associated with electric and magnetic field. They have 1 unit positive charge, and mass is 1.67 or 76 into 10 ki power minus 24 gram, or in kilogram minus 10 ki power 27 kg. Thus, we come to conclude that proton is one of the fundamental particles of an atom. One of the fundamental particles of an atom which carries 1 unit positive charge, and mass is, that is the 1.76 into 10 ki power minus 24 gram or 27 kilogram. Dear students, after a long gap, due to in the middle, in between the discovery of the neutron and proton, it was the radioactivity, the phenomena of disintegration of the heavy nucleus into lighter nuclei. As such, alpha, beta and gamma rays are produced. These are called radioactive rays. And then in 1932, that is the discovery of neutron. Neutron is neutral, no charge, but mass is nearly same, slightly greater than the mass of the proton. Actually, you can consider in totality equality of the mass of neutron and proton, but slightly greater than the mass of the proton in case of the neutron. So neutron is due to the discovery of radioactivity. I can say beryllium, atomic number 4 and mass number 9. Dear students, when it is struck by the alpha rays carry 2 unit positive charge and 4 unit mass. In case of the radioactivity, it is called a charge and mass. Alpha, it is equivalent to the helium. Helium, because of helium still 2 unit negate 2 atomic number and 4 mass number. So dear students, what happens? Nucleus is going to break. So 4 plus 2 6, it is the atomic number of the carbon, and the stable nuclei is 12. Here 4 plus 2 6, here 6, it is 0, it is neutron, it is 1. So it is the reaction, it is alpha neutron type reaction. With the help of the alpha rays, nucleus of the beryllium is destroyed, new element is formed, which is called as carbon, and new particle is existed. That is why it is the discovery of the neutron. Similarly, a series of experiments was conducted by great scientist James Chadwick in 1932 onwards. That is what boron 5 and 11 again struck by the alpha rays. 5 plus 2 7, it is the neutron. Atomic number of the neutron is 7 and the mass number is 14, struck by 0 and 1. So again it is the alpha neutron type reaction. Struck by the alpha, produced by the new particle, neutron, and just like you remember in case of uranium, which I have explained you, law of conservation of mass and energy. There uranium, whenever it strikes by the alpha particle, then the barium and krypton obtained and tremendous amount of energy was released and neutron was formed. Tell me anybody, then how can you define the neutron? Neutron is, one of the, what is their law? Dear students, tell me, fundamental particle of an atom carrying charge 0 and mass is, what is that? 1. So it is the another fundamental particle of an atom. So the way you can explain that atom is composed by 3 fundamental particles: electrons, protons and neutron. And electron means source of cathode rays, proton anode rays or canal rays, and since it also goes through the passage of the pores of the holes, so it is also called as canal rays. And then anode rays, and the neutron, this spread goes to the discovery of radioactivity. This is all about the general idea about the electrons, protons and neutrons. In addition to that, many more subatomic particles present because of due to the research and exhaustive quantitative and qualitative research always from time to time reveal that positron, meson, neutrino, pi positive, pi negative, so many subatomic particles are present in an atom, right? So after that, my dear students, see how to express the atom. Let you X, A and Z. It is very elementary part. Most probably you have done in previous class. A is what is that? Mass number that is composed by the protons and the neutron. Z is actually atomic number that can give the fundamental property of an atom, and X represent a type of element. Right now, so dear students, Z, whatever Z is the number of electron as well as the number of protons in the neutral state, right? So far as neutron is concerned, neutrons are obtained by the subtraction between A and Z. Third, mass number is equal to sum of protons plus neutron. Another very rich information is that if any atom carrying 1 unit positive charge, that means only loss of electron, not protons and neutrons. Similarly here, 5th point is the X pi negative, that means only gain of electron, but not protons and neutrons. So plus and minus is the business of the electron whenever they take part in chemical reaction, they always lose or gain electron. You will study this part in chemical bonding. That is why, see, compounds are formed because of the loss or gain of electron. So I give you few questions here. Dear students, find the number of electrons, protons and neutrons from the given chemical species. Here it is the sodium, sodium 1 positive, and you see calcium, calcium 2 positive. Dear students, electron, proton, neutron and mass number. So tell me anybody, in order to solve such kind of question, always I give you the piece of advice to remember the atomic number right from hydrogen to zinc. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, yes, phosphorus, then sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Right now. So here, whatever the atomic number, and this is the mass number. So 11, proton is still 11, and neutron is 23 minus 11. A minus Z, it is 12. So far as mass number is concerned, that is 11 plus 12, it is 23. Here, sodium is cation. It has lost 1 electron, that means only positive charge representing the loss of electron. Protons and neutrons have no any business with the loss or gain of electron. Dear student, it is 10, 11, 12 and the rest of things will remain same. Just in case of the calcium, tell me atomic number and the mass number. 20, 20 and it is the 20 and it is the 40. But here it has 2 unit positive charge, so electrons, total electrons are 18, right? So here, and then proton is, once again it is the 20, 20 and it is the mass number is, again is 40. So I just take the other examples here. Is it clear to everyone? Just to complete it, I give you a little pause to make you more comfortable and just to make note sincerely and systematically. It will help you to enhance your memorizing power or retention power, because chemistry means, to collect the knowledge, information. It will enhance your growth and subject knowledge. That's very, very important. Right now, my dear students, now I give you another example here. Just I take negatively charged particle. So far as negatively charged particle is concerned, right? You see phosphorus 3 negative, and you can say nitrogen, you can say nitrogen 3 negative. So here electrons, protons, neutrons and mass number. You remember atomic number 15 and mass number 31. So tell me anybody, and what were the electrons? Yes, anyone? 15, proton 15, neutron 16, mass number is the sum of protons and neutrons. Here it is the negative charge, that means phosphide ion. It is electron, here 18, proton 15, neutron 16, mass number will remain same. Just so far as nitrogen is concerned, 7 and 14. So dear students, electron 7, proton 7, neutron 7 and mass number 14. But here it is nitride. Negative charge, that is why it is nitride. It is phosphide. Sulfur 2 negative, sulfide. Chlorine 1 negative, chloride. Halide. Like this. Nitrogen 3 negative. Tell me the number of electrons. Yes, this is the 10, 7, 7 and what is that? 40. So you take your textbook and solve many more questions are related on the basis of how to calculate the electrons, protons and